Okay, so once again, good day to each and every one of you. So, welcome back to another lecture discussion, which is all about current resistance and also electromotive force. Okay, so let's start first with current. Now, if we will define current, current is in the direction in which there is a flow of positive charge. Or we can also define current as the net charge flowing through the area per unit time. Okay, so we have here these two figures. The first one, notice that in this first figure, there is a bunch of positive charges. So notice that the current is on the same direction in which there is a flow of positive charges. Now, on this second figure, notice that it is full of negative charges. But again, notice that the direction of the current is again in the same direction kung asa mag-flow ang mga positive charges. So, maski pag si negative charges are going on the left side or going to the left side, still the current still points in the direction that positive charges will flow. So we call this current as a conventional current. So conventional current is treated as a flow of positive charges regardless of whether the free charges in the conductor are positive, negative, or both. Okay, so let's have a definition of current in terms of formula or equation. So we have current I, capital letter I, is equal to delta Q, or the net charge, divided by the change in time. Okay, so that is again the definition of current. And also, the unit for current is we have ampere or amperes, which is capital letter A. So 1 ampere is equal to 1 coulomb per 1 second, because again, our equation for the current I is equal to the change in the charge divided by the change in time. So charge is in terms of coulomb or coulombs, and delta T or the change in time is in terms of second or second. So that's why 1 ampere is equivalent to 1 coulomb per 1 second, or 1 coulomb per second. Okay, so now let's have the relationship between the current, the voltage, as well as the resistance, which we call as the Ohm's law. So again, Ohm's law is the relationship between the voltage, the current, and the resistance in an electrical circuit. So our equation for Ohm's law is, we have V, which is the voltage. So we have here V is for the voltage, I is for the current, and we also have capital letter R, which is for the resistance. Okay, so here are their terms together with their symbols. So they are all have capital letters na symbols. So V for voltage, I for current, and R for resistance. So this is the relationship between the current, the resistance, and also the voltage. So Ohm's law states that the voltage across a conductor is directly proportional daw, see, voltage to the current flowing through it, provided all physical conditions and temperature remain constant. Okay, so now, let's say for example, we are asked to solve for the current given the voltage and the resistance. So to solve for the current, we will just transform this equation. So let's have V is equal to IR. So to solve for current, we divide both sides with R. So current is equal to V over R. So this is for the Ohm's law if you're asked for the current. Now, if we are also asked for the resistance, so resistance given the voltage and the current, so resistance is voltage over current. So here are the equations of to solve for the voltage, the current, and the resistance for the Ohm's law. Okay, so now let's proceed with power or electric power. So power or electric power is the rate at which energy can be transferred. So our equation for power, we have P, capital letter P, is equal to the product of the voltage times the current. So again, when you're asked to solve for power, power is the product of voltage and current. Okay, so we can also have the equation for power in terms of not only for voltage and current but also for current, resistance, current and also resistance. So if you're asked to solve for power given only the current and resistance, now take note na from Ohm's law, V is equal to IR. So if ang given lang nato is in terms of current and resistance, we can substitute V as equal to IR. So our P now becomes IR times I is I squared R. And also, in terms of voltage and resistance, we can also have the equation for power as, now take note that resistance, or we have the current is equal to V over R. Okay, so now V times V over R for the current is equal to V squared over R. So we can have either of this equation. So again, using the general equation for Ohm's law, which is V is equal to I times R. So depending on the given, if ever we are asked to solve for the power and then the given is in terms of current and resistance, so we can use this equation. And also, if we are asked to solve for power given only the voltage and the resistance, so we can also use this equation. So again, as long as you know how to derive the equation or how to transform the equation by using Ohm's law, you can get the equation for power regardless on kung unsay given nga value. Okay, so for the unit of power, we have watt or watts. So capital letter W. So 1 watt is equivalent to 1 joule per second. So this is the equivalent of watt. So again, 1 joule per 1 second. Because again, from the definition of power, it is the rate at which the energy can be transferred. So the unit for energy is in terms of joule or joules. So again, unit for power, we have watt or watts if it is plural. Okay, so we have here an example. So a current of 3.8 amperes flows in a wire for 12 minutes. So the question here is how much charge passes through any point in this circuit during this time. Okay, so let's write first all the given values. So we are given the value of the current I, which is equal to 3.8 amperes, and then also the time, which is equal to 12 minutes. Okay, so now take note that our time is in terms of minutes. So we first need to convert from minutes to second. So we have here 1 minute is equivalent to 60 seconds. So 12 times 60 is, we have right here, 720 seconds. Okay, so from the equation of the current, diba, current is equal to the charge per unit time. But again, we are asked to solve for the charge. Kaya atong given is in terms of current and time. So we need to multiply both sides with time so that it will be cancelled out. So we have Q is equal to the current times the time. So we have the value of the current and we also have the value of the time, so we can solve for the Q or the charge. So we have here current is 3.8 amperes times the time, which is 720 seconds. So 3.8 times 720, we have here 2,736, and the unit for the charge is in terms of coulombs or coulomb. So the charge, the amount of charge that passes through any point in this circuit is equal to 2,736 coulombs. Okay, so let's proceed to another example. We have a 9 volts battery is connected across a 250 ohm resistor. Okay, so let's draw first before we solve for each of these questions. So let's say we have this battery right here. So this one is the positive, kaning longer nga line is the positive, and this one is the negative. And it is connected, let's say, to a resistor. So this is a 250 ohms na resistor, and then we have the battery, which is equal to 9 volts. Okay, so the question for letter A, let's start with letter A first. How much current passes through each resistor? So again, our given values are in terms of the voltage. This is equal to 9 volts, and then we have the resistor, which is equal to 250 ohms. Okay, so we are asked to solve for the current. Now for letter A, we will be using the Ohm's law, which is V is equal to I times R. So since we are solving for the current, divide both sides with R so that it will be cancelled out. So current is equal to V over R. So we have the value of V as well as for the resistance, so we can solve for the current I. So we have 9 volts divided by 250 ohms. So 9 divided by 250 is equal to 0.036, and then we have the unit for current is ampere. So we have now letter A. Now for letter B, the question is how much power is dissipated by the resistor. Okay, so power dissipated by the resistor. So we'll be using the value of the resistance to solve for power. Okay, so for our previous equation for power, diba, we have 3 equations for power. We have P is equal to VI, V times I. We also have P is equal to I squared R, and P is equal to V squared over R. So again here, we are asked to solve for the power dissipated by the resistor. So in this, out of these 3 equations, we can solve for, we can use this second equation to solve for the power. So we have here P is equal to I squared R. So we have our current, which is 0.036 ampere quantity squared times the resistance, which is 250 ohms. Okay, so we have right here 0.036 quantity squared times 250 is now equal to 0.324, and then again the unit for power is in terms of watt. Okay, so let's proceed with letter C. For letter C, the question is how much power is delivered by the battery. So si battery na pod, so which is the voltage. So we will be using this equation P is equal to V times I to solve for the power. Okay, so we have V as 9 volts times the current, which is 0.036 ampere. So we have 9 times 0.036 is equal to the same answer, which is 0.324 watts. Okay, watt. So, notice na the power dissipated by the resistor and the power delivered by the battery is the same. Because again, notice na kung pila man gani ang ginahatag nga power ni resistor, since again, we only have one resistor, so the power nga gi-dissipate ni resistor as well as nga gi-deliver ni battery must be equal or must be of the same value. So, that's why we have for B and C, the power dissipated by the resistor, which is 0.324, is equal to the power delivered by the battery, which is, again, still 0.324. So, that is for our second example. Now, we proceed to the next example. So, another example, we have a 12 volts battery is connected to a light bulb and draws 150, we have here, MA is milliampere of current. Okay, so before we start solving for A and B, let's write the given first. We have the voltage, which is 12 volts, and we also have the current, which is 150 milliampere. Now, milli is times 10 to the power of negative 3. So, 150 times 10 to the power of negative 3 ampere is just equal to 0.15 ampere. Okay. So, because again, we need to convert from milliampere to ampere for in solving for letter A and letter B. Okay, so now for letter A, let's start with letter A. Letter A is what is the electrical resistance of the light bulb, which is C, capital letter R. So, using the Ohm's law, V is equal to I times R. To solve for R, divide both sides with I, so that it will be cancelled out. So, R is equal to V over I. So, we have 12 volts divided by 0.15 ampere. So, 12 divided by 0.15 is equal to 80 ohms. Okay, so this is the electrical resistance of the light bulb. Now, for letter B, we are done with letter A. Now we proceed with letter B. So letter B is how much power does it consume? Okay. So the formula for power that we will be using is the power is equal to V times I. So we have the value for V as well as for I, so we can solve for the power. So we have 12 volts times I is 0.15 ampere. So 12 times 0.15 is equal to 1.8 watts. So this is the power that is consumed by the light bulb. So again, for the third example, for letter A, the electrical resistance of the light bulb is equal to 80 ohms. And then for letter B, the amount of power consumed by the light bulb is equal to 1.8 watts. Okay. So now here, let's proceed to the resistors and also the resistance. So we are done with the voltage and the current. So we will now proceed with the resistors as well as its resistance. So resistance, when we say resistance, it is the ratio of V to I for a particular conductor. So again, from the Ohm's law equation, which is V is equal to IR. So to solve for the resistance, given the voltage and the current, so we have the resistance is equal to the voltage divided by the current. So the unit for resistance, we have ohm or ohms. So this symbol right here is what we call the omega. So this is an omega. So 1 ohm is equal to 1 volt per 1 ampere, because again we have R is equal to V over I. So V, for the voltage we have volts, for the current we have ampere. So that's why we have 1 ohm is equivalent to 1 volt per ampere or 1 volt per 1 ampere. Okay, so how about for the resistors? Unsa maning resistors? We have here a figure that is an example of what a resistor looks like. So we have here different types, different resistors of different resistances. Okay, so resistor is a circuit device made to have a specific value of resistance between. So now, as you can see here in the figure, each of these resistors have different like colors, color bands. Color bands as what we will describe it. So this first resistor is different, have different color bands than this another resistor as well as on the other resistors. Now, nganong lahi-lahi man ang color bands or ang colors sa mga bands ani nga mga resistors? It's because, again, each of this resistor has a different value of resistance. Now, unsa may purpose? What is the purpose of these colors right here? Now, the purpose of these colors is to determine the value of the resistance without measuring it using a device. So, let's say for example, you're asked to buy a resistor of a specific resistance. So, since wala man ka nagdala og device, but you can still determine the kung unsa siya nga resistor ang imo ang gipangita based on the color codings of this resistor. So as you can see here on the right side, we have the color codes for resistor. So common nga resistor has 4 bands. So we have the first band from left to right ni siya actually nga pag-measure sa resistance or pag-determine sa value sa resistance sa isa ka resistor. So we have on the first band determines the first digit of the value of your resistor. The second band determines the second digit. The third band determines the multiplier. Now, unsa man si multiplier? Multiplier is times 10 to the power of pila ba ka? 1 or times 10 to the power of 2, depending on the color. And then the fourth one is what we call the tolerance. Okay. So, let's look at here table 25.3. So, we have this sequence of colors. We have black, brown, red, orange, yellow, green, blue, violet, gray, and white. So, ang value niya as digit is from 0. So, black is 0, brown is 1, red is 2, orange is 3, 4 is yellow, green is 5, blue is 6, violet is 7, gray is 8, and white is 9. And also, ang value niya as multiplier, for black, we have times 10 to the power of 0, which is equal to 1. 10 to the 0 is just equal to 1. Brown is times 10 to the power of 1, which is equal to 10. And then we have the red is times 10 to the power of 2, and so on and so forth. So, this is what we would mean by multiplier. Okay. So, how about for the tolerance? Now, for the tolerance, we have only 3 colors. So, it's either no color or no band. When we say by no color or no band, it's either ang makita lang ninyo sa resistors are only 3 colors. So, walay ika-fourth nga color. So, pasabot ana it's no color or no band. So, si no color and or no band has a tolerance of plus minus 20%. So, mo ni iyang tolerance. Now, we also have for, let's check for, wait a minute. Okay, so for no color or no band, again, it is plus minus 20%. And then we also have silver, which is, ang tolerance niya is plus minus 10%. And we also have the gold, which is equal to plus minus 5%. So these are the values of the tolerance for each color nga assigned on the fourth band. So again, the first band is the first digit. So let's say for example, this figure right here. So we have the first digit is green. So green is 5. And then we have the second digit is violet, which is equal to 7. And then we have our multiplier is red. So red is times 10 to the power of positive 2. And then we have our tolerance is silver. So silver is plus minus 10. So we have plus minus 10%. So the resistance of this particular color nga resistors is equal to 57 times 10 to the power of 2 and then plus minus 10% ohm. So again, this is now the value of the resistance for this particular resistor. So again, as you can see right here in the figure, let's look at this resistor right here. So we have the first band is, okay, so don't be confused kung asa mo dapit una mag-measure. It's because manotice ninyo nga if ang inyong una nga makita nga first colors or first band is either gold, silver, or even no color, so that is the tolerance. So pasabot ana baliktad, dili na siya mao si first digit. So you will go to the other side. So notice here nga the first is, I think it's red. So red is 2. So we have 2. Second digit is black. Black is 0. And then we have the third band, which is the multiplier, is also black. So times 10 to the power of 0. And then we have our tolerance is gold, which is plus minus 5%. Sorry. Plus minus 5% ohms. So we have 20 times 1 plus minus 5% ohms, or the value of the resistance of this specific resistor is just 20 plus minus 5% ohms. So this is the value of the resistance of this resistor by looking at the colors. So it depends on you kung saan ninyo pag-memorize sa sequence of colors. So again, we have black, brown, red, orange, yellow, green, blue, violet, gray, and white. So it's either you make an acronym or whatever is like comfortable to you kung saan ninyo pag-memorize sa sequence of colors. So from black to white, and then the value as digit is from 0 to 9, as well as the multiplier. Again, when we say multiplier, times 10 to the power of 0 to times 10 to the power of 9. Okay, so let's have an examples on how to determine the resistance of a specific resistor. So example number 1, let's say the sequence of colors are green, blue, orange, and silver. Okay, so we have, this is our first band, green. Second band is blue. Third band or the multiplier is orange. And then we have silver as our tolerance. Okay, so green here is 5. Blue is 6. Times orange is times 10 to the power of 3. And then we have our tolerance, silver is plus and minus 10% ohms. So meaning, the value of the resistance of this specific resistor is equal to 56 times 10 to the power of 3 plus minus 10% ohms. Okay, another example. let's say we are given the value of the resistance. So we are about to determine the color or the color code of the resistor. So 72 times 10 to the power of 5 plus minus 20% ohms. Okay, so what if that is the value of the resistance? So how can we determine the color? So 7 is violet, and then we have 2 is red. And then times 10 to the power of 5 is green. And then we have the fourth one, the tolerance is plus and minus 20%, or we can also write it as no color or no band. Means now we have no fourth band or no color for the tolerance. So you can also write it like that. So again, that is how you would determine the value of the resistance by looking at the color, the series of colors of the resistor, and also if you're asked to if you're given, the value of the resistance, and then you are to determine the colors of the resistor, or the other way around. So again, it's really important to memorize these color codes of the resistors. So from black to white, valueless digit is from 0 to 9, as well as for the multiplier. So basta sa multiplier is times 10 na siya, times 10 to the power of 0, 1, 2, 3 up to 9. And then we have for the tolerance is we only have 3, which is the no color or no band, the silver, and also the gold. So that is how, again, you would determine the value or the resistance of a specific resistor based on their color. Okay, so for our next topic is we will be discussing all about the resistors, how to solve for the total resistance in series and in parallel, or in the combination of series on in parallel. So that is for our next lecture discussion video. Thank you.